We are going to expose our project that it's a capsule designed to control humidity inside the boxes of exportation of fruit in order to reduce losses.
It works by controlling the humidity levels and leaving them in the optimum range that each fruit needs, because they have a specific level. So the capsule keeps that for the whole trip. That could take around 40 days sometimes. So yeah, by that we can reduce the losses by 46%.
And up next we have Cohex here from Santiago, Chile.
Hello everyone. My name is Lucas, and with Josefa and Maurizio we're here to present you our project Cohex. Well, first of all, did you guys know that almost 50% of all the fruit and vegetables that we produce around the world gets wasted every year? We don't only waste the product, we also waste all the materials needed and for doing this fruits and vegetables, like the water, the land, the labor, energy, and we emit a big amount of greenhouse gas emission that we shouldn't be emitting. This happens from the very moment that the producer plants the seed till the last moment where we as last consumer eat it. But the hardest part to control is exportation. This happens for the next reason. We have to think that the fruits are alive, they breathe, and we need to keep them under control for long trips that are up to 40 days. The producer has no connection with this fruit while traveling. He cannot check it, how it's doing, how the variables are. And the two variables that they need to control is humidity and temperature. Temperature is not much of a big problem because there's a cold change and it's under control. But the situation with humidity, it's a bit harder. This can even worse when we're talking about grapes and berries. For these fruits, we lose about 8% during exportations, and it is about 500,000 tons of fruit. That's a really big number of good fruit that could be saved every year, and it's about $1.1 billion that we lose per year. Now, for this part of the project, we focused on grapes because they're the ones that get more damage. So from now on, we're going to talk about grapes. The problems that we get with grapes by not controlling the humidity are fungus, dehydration, and white spots. Why does this happen? Every fruit has a level of humidity that they need to keep in optimum conditions to be healthy during the trips. For the case of grapes, it is 95%. If the humidity rises, we will have fungus and white spots, and if it drops, we'll have dehydration. Now, how has the industry been solving this problem? It's with this packaging. So what they do is that they put a plastic bag over it to control the temperature, but this raises the humidity. With this, they get fungus, so they had to add another material that it's a sulfurized paper layer that controls the fungus. But if the humidity rises even more, they get white spots. So one solution makes another problem. So for this, they have to add another material that it's an absorbing paper. And with this, they have a quite good solution to save 92% of the exportation. Now, as you can see on the picture, even with all of this, they still have condensation and water, and this is the perfect condition for the fungus to grow. So what have we done? We have designed a capsule that controls the humidity levels inside the box to have the optimum condition for each fruit. We can actually configure the proper level that we need, and it works like this. We're going to show you a video. So we did a box. This is the inside of the box and the outside. We raise the humidity, and our material can actually sense and act to this. When it reaches center level, it opens and lets the air flow through to take the humidity from the inside to the outside. Here you can see a little string going out. It works as well for temperature, so the cooling process is actually faster. And when the temperature rises, it opens up again. This was made to reach the needs that USDA requires and the FDA. So the capsule that we've done actually can take humidity or give humidity as needed. Now let's talk about competition. As we said before, this packaging has been in the industry for around 30 years. It hasn't changed much, but here are two innovations that we would like to name. The first one is Smart Pack. that what they've done is they took the bag and they add the sulfurized layer to the bag. So they reduce the amount of packaging and the airflow, it's better inside the box. The next one is alga paper, that it's a paper made of a special seaweed that kills the bacteria when in contact with it. Now, what's the big difference between us and them? We are attacking the cause of the problem, the humidity levels, and this guy are attacking the symptoms after what they get. So, in money savings for the exporter, we have estimated that we could save around 46% of the losses. This would mean that we could save around 220,000 tons of fruit. And in the market, we will be saving the industry around $515 million. Our packaging is as well more efficient. It's 30% faster to assemble, and it has less materials. And there's other benefits, as the cooling process, for example. Our process would be at 20% faster to bring the temperature of the pulp down. This is quite important because the quickest you bring the pulp temperature down, the better the quality it will have, and the fruit will be more healthy for the trip. Because once you cut the fruit, it starts aging. So you got to do that very quick. This would make a reduction of the cost of cooling it by 16.7% cheaper. And there's as well social benefits for all of the last consumers, that it's us. We won't be needed to use sulfur, which is good for the health, not to use it. And actually some countries in Europe are asking people to innovate to not use sulfur anymore. We'll reduce as well the amount of waste that we are dropping to the land. And as we said before, that was with the grapes, but if we add the market of the berries, we would be talking about a market of $1.5 billion every year. We can reach this because our product is very cheap. Nowadays, the companies are paying for this kind of packaging around $3.50. We will take a bunch of materials from here. We will add our cost, that it's only 53 cents. So we could be able to charge $1.67. Now, if we add all the benefits that we bring to the companies as well, we have estimated that we could charge around $2.66. Now, how are we going to get to this market? We've been working with this company that's called Subsole. It's one of the biggest companies in Chile to export fruit. They've been in the market for more than 20 years, export more than 400 products to more than 40 countries. And we've been learning from them how the process works, and we would like to make an alliance with them to learn how the exportation process is, to have the knowledge for the detailed parts. What are our next steps? Well, we would like to get to the production stage. For this, we will need around $34,000. Then comes the market entry, and at the end, the market expansion. For the first part, we will need around 9 months, and market entry would be 2 years working with Subsole, and after that, we'll be able to open and expand the market. Now, we've been working with our university for the patent process, for the labs, a couple of professors, and the installations to do all the fabrications that we need for the capsule. With Subsole, as we said before, to get to know the industry and how the process are. And there's as well INIA, that it's an institute of the government that will help us to know that we're reaching all the needs that the government needs in the exported land. For example, the USDA and FDA here. And we're working as well with ASOEX, that is an association of Chilean producers that will help us to reach international trading. Now, we believe that companies nowadays don't have much responsibilities of what they waste, of their waste. We would like to change this and have responsibility of this by redesigning a more efficient product with less waste. And what we mean with this is that our capsules could be made by recycled plastic, and we could change the configuration of it. So we could send, for example, grapes from Chile to the States, take the same capsule, open it, rearrange it for the next fruit, and send, for example, blueberries from the States to Canada. So there's a reuse of the capsule. Now let me please introduce you our team. I am Lucas, Josefa, and Maurizio. We're working as well with our advisor from our university. He is Alexandro Tsamis. He has a PhD in MIT. And we would like to answer all the questions that you have. Thank you very much.
Excellent job. This is not my first question, but I think we'd all like to know, just really quick, is that what we see in front of us? Is that the package itself, and then is that like a battery operated opening and closing of the vent system? Just want to make sure I don't know, maybe I don't know if that's a good question. Yeah. Does that make sense?
Sorry. It actually senses the humidity. You can show that, and it reacts to it. And that's enough. That's enough. It opens.
That would agree. Okay.
Yeah. The same happens with temperature.
Okay. All right. Once again, excellent presentation, and what a really interesting idea. My one question, I didn't quite understand the. I thought your going to market was very realistic. I mean, from a revenue cost, I think you got your head around that. For you to get onto that runway and get going, how much money do you need to get that completely? Here we go. 3 years. We're 2 years in. We got 2 years of runway. What is that cost looking like?
Well, we have estimated a 9-month phase for productionizing this project. We have for that estimated we need $34,000 just for getting the technical requirement and the development requirement for the production. That is a research phase. So just for taking to the stage of knowledge of what to product, we need just $34,000. After that, for entering the market, we have estimated the $350,000 just for making the production up.
Is your plans to basically target, is it Subsol as your partner in this? Are they going to have an exclusive, or are you expanding out to other shipping producers?
Okay, so we will work with Subsole at the beginning of our project, giving to them a discount for 2 years, an exclusive discount for them. But we are not going to work with them an exclusive. So we are going to have more clients in the second year. We will start with them. And we estimate our cash flow with just with the 1% of the market that they have now. So yeah, the answer is that we are going to give to them a special discount, and we consider it in our cash flow to calculate the payback.
A couple of questions. One is just a curiosity. It seems like very light, but compared to the traditional packaging, I'm assuming there is no increase in weight because you are exporting and you don't want to have a weight increase, right?
Mm-hmm. It's actually like the same weight because this is not so light. It's a little bit loud because it has like a bit of sand inside. It's a chemical that produce the sulfur gas, so it's not so light.
Mm-hmm. Okay. And I'm assuming you have some patents on it.
Yeah, we are working on it. We already applied the field form, and we are working on the CPT scope for the protection in US and other countries for the exportation.
It is already in process in Chile and in the US.
So, yeah, I just want to follow up on that. So, first of all, I have a degree in material science, so this brings joy to my heart. But talk to me about, I mean, you're going to need a lot of these. What is the plan for production? I mean, they're probably not so expensive to produce, but it seems like a high volume. So can you give me a sense of the kind of the numbers of that?
The main cost of production is actually assembling this capsule. So we have estimated that in the first years they are just hand assembling. But after that, we are considering to obviously invest in some machines to do it automatically. But we have estimated the numbers of capsules you can actually assemble in a period of time for reaching the demand. Yeah. So we are considering that only also in the cash flow.
So we're not going to produce every part of this. We will externalize this. So we would ask, there's 4 systems inside the capsule. So we'll have 4 companies working, sending us every part of the material that we need, and then we just assemble it. With this, we can reach a higher number of production.
But for scaling, you could have a contract manufacturer do all of that for you at some point?
Yeah, like one company doing all of it.
Yeah, I mean...
Yeah, assembling,
right.
yeah. There's actually, for example, there's the materials that works with humidity. It's a cellulose with a kind of plastic, and there's companies that do that already. The same with the temperature and zeolite. So it's not something that we're going to have to ask the industry to create. We'll have to tell them how the specifications are, and they can already put that in their line of production.
Okay. So then, are you going to send a bunch of these boxes with grapes through the Panama Canal and test this in the field and try to do a comparison between, as you're trying to acquire customers, between the way it's being done now and the way you're going to do it?
That's it. That's the idea of working with Subsole, that they can let us do that. Like, we could do up just one pallet with our product and send it with the rest of the traditional packing, and then compare how the quality is.
Okay. I had a question also about the testing. Can you tell me a little bit about the testing you have already done?
Yes. So it would be good to explain you quick about the capsule. So as we said, there's 4 layers. There's one in the middle that we can see yet that it's for the temperature. And we have experience and experiment how the opening and closing is, and to the certain level that we need. You can do that by arranging the temperature where you put 2 materials together, and then you set a point where you want it close. Then the difference of temperature you can manage between the shape of the card and the materials. The same happens with this material in the middle is zeolite, that it's a mineral that has the ability to absorb or release humidity depending on the atmosphere it is. We have done some experiments with that as well. And the 2 other layers are the one that work with humidity. Having that in mind, we have done... this is zeolite, and we checked how it works when it is humid and how it can release. And we did the same experiment by checking how it absorbs, and we got the percentage that we needed. We did the same in the cold change. We put a packaging with the fruits and saw how the process was, and we got actually. Can you put the one of the cold chain? And this is a graphic that shows the actual packaging, and with at the cold tunnel, how it brings the temperature down. So we have checked every system inside the box, and they all work. The part that we have to do now is put them all together, and that's why we need the money for.
Okay. And then one last question. You had mentioned something about 2.66 that you could charge more.
Yes.
What exactly are you trying to... How are you going to charge extra for it?
No, we don't want to charge extra. We just want to show that we could, like the yellow box is the range we have to charge. So we are thinking about setting it probably at the same price that the actual package, because this is innovation, and that's what innovation is about, improving, and it doesn't need to be more expensive. But in the case of we're saving money, so in the economical world we could charge more because of the advantage that we give.
One of the questions is, you're a solution to a problem. Whose problem is it? Is it the grower's problem? Is it the end user's problem? Who's driving this? Who's upset about 45% of the fruit going bad? The seller or the buyer?
Well, in the beginning, we would think that it's the exporter, right? It's his money, his pocket. If the fruit goes bad, the people on the other side of the world won't buy this part of the fruit, so he loses. But nowadays, it's a global problem because food waste and food loss is a big material coming. It's like the next global warming. So the ONU, United Nations, are actually trying to innovate and find solutions for not losing food, not waste. So it is in the principal part for the producer the pain, but it is a global problem that we are helping to solve as well in a little part.
Yes, and we didn't. Well, the solution was for them at the beginning, but we didn't do something just for them and create more problems to the society or create more waste. So we consider that, but we, the exporters, will be the principal beneficiaries with the money that they will save, and also we always think in the environment. Like, we think that's the way we should create innovations today.
Just one more thing before we do the questions, and I think we'd all say this to you, is you don't have very much cost to get this going. I would absolutely spend the money on an independent study that follows a grape, or two grapes. One grape in your box and one grape over there. And they follow it through the Panama Canal all the way up to wherever it's going to go. And that study is something from an independent, like what the cost of that is going to produce so much in revenue if you're right in what you're saying. That's your last validation before stage 2 you get really cranking into the market. That's going to really validate you. Spend the money on that. I have to say that to you because I think you guys are on to something.
Okay, a couple online questions. If your device opens to the outside, how do you avoid contamination?
It closes during the cold channel, and it makes it more efficient because if you close one box, then the air would go through the other ones that are not closed, and it keeps closed till the end of the trip, and it actually opens up only once you take it out of the container and you put it in the atmosphere, in the atmosphere of the ambient where the temperature is higher. Then it opens. The normal boxes, once you put it out, they're open as well, so it's no more contamination.
Okay, if the capsules can be reused, how much will that affect your sales?
Well, if we start going with the idea of reusing the capsule, we won't then just sell them as a product. We would change our company into a service company. So we would make sure that your grapes get delivered with this amount of humidity. Then we would take the capsules, we would rearrange them, and we would give the service again. So it would be more like a service company.
Have you practically tested how many times you could reuse this? At what point does the material kind of start to not perform at the levels that you're speccing out? I'm just wondering about that. Have you cycled it over and over again to figure that out?
Yeah, that's for now. The product that you see is just handmade in our university, just paper and plastic. So we need the money just for that to develop a better product and to make this for how many times you can reuse this paper. If not, the service company we are thinking about for the reusable capsule is thinking of reusing the capsule, the plastic structure, and rearrange the layers of paper. But the zeolite, the good of it is that it can be absolutely reusable. It has the ability to absorb and release humidity very easily, so we can reuse it as we want. It's just the paper that, in fact, is the cheapest material.
Just one last thing. These boxes are packed against each other, on top of each other, next to each other. Does that affect the ability of the system to actually open if there's a box right next to it?
Not at all, because the capsule is designed just for this kind of door. It's opening, but it's designed to have the space to it. So just they open inside this capsule, not out of this layer. So, and they also designed to, because the boxes are arranged in this palette, just one to the other side, and the airs come through this direction. So they are considering the whole airflow.
And also we mentioned that the cost of energy will be lower because we design just one channel to get the air get into the box, because it is in our investigation papers, everything, we get that it is much better to have one channel to get the air into the box than too many as the bags today have. So it is not efficient at all. That's why we did just one capsule, and the other box is going to be here, so the air flow can go just in one direction and be more efficient and save money for the energy to get the fruit colder.
Thank you. All right.
Thank you.
It's my pleasure to introduce James Schultz from Plastics One to award the Manufacturing Award. James?
Wow, what an honor it is to be amongst you from all around the world. Really impressed just to read some of the portfolios that were out there, and I probably don't get to say too much, but I was really impressed with what you guys have done. It's exciting to have so many dreamers in one room. I think we all, whether you're old or young, you want to dream what you guys are doing today and what you're doing here. America was founded on the dreamers that we have, and I work with a lot of great dreamers. They drive me crazy because I have to actually get it to make it functional. But it's really a pleasure to be up here before you guys, and after much careful deliberation on part of the judging panel, not myself, I didn't have a say in that one, but the winner of the 2017 Plastics One Advanced Manufacturing Award and $10,000 prize is Cohex from Santiago, Chile.
Thank you.
So the next prize is the $15,000 add-on to one of those two teams. The guys from Chile were so excited to win. I mean, let's give it to them. What do you say? Come on back.